So the first question which you have sent me, that is ax plus by is equals to a square minus b square, and bx plus ay is equals to 0. Find the value of x plus y. That means we have to find x and y at first, right? Whoever have already attended the class of here, Aisha, Abdul, Alvina, you have not done, no? Pair of linear equation? Okay, so here no one has done pair of linear equations. So
chapter.
Okay.
We were doing first chapter, real numbers.
Yeah, I was doing first chapter, that is real number. Arya, I'll send the solution to you. Okay.
Okay, ma'am.
Because no one will be able to understand whatever we'll be doing over here. They have not done pair of linear equation. Just after this class, I am sending you the detailed explanation of this one. Okay, Arya?
Okay, ma'am.
Will
Can I
that
leave?
help?
Yes, ma'am.
Okay. Okay, Arya. So keeping it, you, if you want, you can do your preparation.
Thank you, ma'am. Have a good day.
Thank you. Best of luck, Arya. Okay, so rest of the student, let's continue. We were doing real number, we will be continuing that. We would have taken this question if the topic we would have covered with all of you, but we have not covered, we are not going to take this question. For now, we are not going to take. Real number, we were discussing LCM, SCF. Previous day, one formula we have discussed, that is the product LCM into HCF is equals to product of two number. We have seen this formula also in our previous class. So if we are having a question, just a moment. If we are having a question that given that HCF of the given number 306 and 657 is equals to 9, find LCM of the same. See, whenever the question will be like this, we are supposed to use the above formula. The formula which we have written over here, that LCM into HCF is equals to product of two numbers. This formula we are going to use over here. Okay. So let's use this formula. We know the formula. Here, see carefully the question. In the question, it is given that HCF of these two numbers is 9. Find the LCM. Find the LCM by doing prime factorization? No. Find the LCM by using the formula, which is the relation between HCF and LCM. That's why this HCF is given. Now, if we have to use the prime factorization only, if we have to use find the LCM by using the previous method only, we will do the prime factorization of 306, we will do the prime factorization of 657, and we will see what is the LCM. Then why this HCF will be given in this question? Since this HCF is given, we have to use it. Okay, how we'll be using? Let's do that. So the formula we are going to use over here, that we know that there exists a formula, that is LCM into HCF We are talking about LCM of two same number, HCF of two same number is equals to product of two numbers. This is only applicable for two numbers, two integers. Okay, it is not the same formula. We cannot say that it is the same formula. We cannot apply for three integers. We can find the LCM and SCF of three numbers, four numbers, five different numbers, but the formula is only this formula which I am going to write on the screen with the red color marker. LCM into SCF is equals to product of two numbers. This is only applicable for two numbers. Okay. So LCM, we don't know. What is SCF? SCF is given as a 9. We are going to substitute this value over here. Okay, we are going to substitute this value over here. LCM we have to find product of two number. Which two number? The two number, those two number, we are using those two number and finding the LCM. We are using those two number and finding the LCM. We are talking about the LCM and SCF of these two number only. That two number we have to take over here. That is 306 and 657. Product means multiplication. So 306 into 657. Are you getting it? When we'll be having this type of question, how we are going to solve it?
Yes.
Please do the calculation and let me know what are you getting as a LCM.
Ma'am, can you scroll up?
Yeah, sure. Please find the LCM from here. Are you doing it? Yes, Ifra. I have given this question. Given that SCF is this, find the LCM, and I was explaining that whenever this type of scenario will be having, we have to find the LCM by using the formula only. Please find it.
Yes, ma'am.
Have you got it? If you are doing the multiplication on the right hand side, please don't do the multiplication. You can directly shift the 9. Yeah, I didn't get it. Okay, Ifra, I am saying, can you see the question?
No, I got the answer.
Okay, this is the yes, I am coming to the answer and the solution part. Just give me a second. Okay, so here we are having the question, Ifra, that is given that HCF of 306 and 657 is 9. find the LCM. I have explained that whenever we will be having this scenario, this type of scenario, then we are not going to find the LCM by doing the prime factorization, because here one information is given to us, that is HCF is 9. That means we have to use this information. To use this information, there exists a formula. The formula which we have written over here. We know there exists a formula, and the formula is this one, the underlined one. This one. This one is the formula. Okay. That LCM into HCF is equals to product of two numbers. This is a formula. Okay, we have written directly the formula. Previous day when we were doing we were finding the LCM and SCF of 6 and 20. Then we have verified this formula also. Yes, it is true. Okay, so here we are going to use this formula. Why we are going to use this formula for finding the LCM? Because HCF is already given. We have to use that HCF. So here we have just substituted HCF, which is given. Product of two number means the first number 306, the second number 657. And then I said to everyone that do the calculation over here and find the value of the result of the LCM. Yes, Aisha, you said that you have already got the answer. Or Alvina,
Yes,
you
ma'am.
said.
Ma'am, Aisha.
Yes, Aisha, what you got?
Ma'am, I got 22,338.
Is it this? Have I written it correctly?
No, ma'am, remove the zero.
Okay, zero is not there. Just a second. Yes, rest of the students, what are you getting?
Ma'am, remove the 2 also.
It is not 22, it is only 2,000. Aisha, what you have got? Are you saying to wipe this 2 also? 2338 you are getting? Rest of the students, have you done the calculation? Abdul, Alvina.
I'm not getting it.
Yes, Alvina, what you say? You are doing it or you are not getting it?
I'm unable to get down.
Can you please repeat?
I'm unable to get down.
Okay, you are unable. Okay, no worries. We'll be doing it over here. Abdul. Abdul. Yes, Abdul, have you done the calculation?
Yes, I'm getting.
Are you getting the answer?
Yes,
What you got, can you please let me know? I'll write over here.
22,338.
Hmm?
338.
This is what you are getting, Abdul?
Yes.
Let's check it. I said to you, please don't do the multiplication on the right hand side directly. Yes, Aisha, you are also here. I said to
Ma'am,
everyone,
sorry.
please,
Ma'am, sorry, I was disconnected.
no worries, Aisha. We have not,
No, by mistake, I told you to remove two.
so is it 2,338, Aisha?
No,
Let's
it's
check.
22,338.
Okay, okay, fine. Let's check it over here. Whatever you have got, that's what we are going to get or not. We will not do the multiplication of 306 and 657. We will not do the multiplication. We will write it as it is, 306 and 657. And this 9 from the other side, we will take it and we will write it in the denominator. Now we will see if any number which is possible to cancel by this 9, yes or no. So 306, we can say it is going by 3. 9 is also going by 3. We can take that. 3 times 9, 3 1 times 3, 3 2 times 6. Okay. Now 102 we are having, and the divisibility rule of 3 is if the sum of the digit is divisible by 9, if the sum of the digit is divisible by 3, we are talking about 3, then the number will be divisible by 3. You see this 102, if you will add 1 plus 0 plus 2, if you will add the digit, it is 3. That is divisible by 3. That means I am saying it directly that 102 is divisible by 3. Now you must be thinking how I got to know that 102 is divisible by 3, because we must know the divisibility rule of each and every number. So divisibility rule of 3 says it is divisible by 3. So 3 times 9, 3 4 times 12. We got 34 in the numerator. What is in the denominator? Nothing. 1 is there in the denominator. So in the numerator, we are having 34 into 657. This is what we will be doing the multiplication now. Previously, see carefully, I have not done the multiplication of this 3-digit number with the other 3-digit number, because that will again very larger number, and that we will start thinking to cancel out by 9. Okay, better than that, just let it be like that and just take 9 from the left hand side, which is there in multiplication. On the other side, it will be in division. That's it. Okay, this is what we got. 34 into 657 we got. So 657 we will multiply with 34. We have to do the multiplication over here. 7 4 times 28, 8, carry 2. 5 4 times 20, 21, 22, 2, carry 2. 6 4 times 24, 25, 26. 7 3 times 21, 1, carry 2. 5 3 times 15, 16, 17, 7, carry 1. 6 3 times 18, 1, 19. 8 3 3 6 7 13, 3, carry 1, 2 2 2 2 3 3 8 we got. Please do the multiplication the way you do multiplication, same like just the basic calculation we have to do over here, and we will be getting 2 2 3 3 8. Okay. Yes, Abdul, you also said 2 2 3 3 8.
Yes.
Yes. So you also said the same answer. I have written it double 8 at last. This is what we are going to get. Yes, Aisha, it is correct. You have already got double 2. Okay. Yes, Abdul, it is correct. Alvina, are you getting it? We just have to do the calculation carefully.
Yes,
Getting
ma'am,
it,
got it.
Alvina?
Yeah.
Yes. Ifra, you are there? Ifra, are you getting it? What are we doing over here? We have just used the formula, Ifra, and we have substituted the number. Other side, we have taken LCM into HCF, which is given 9, and this side, product of two number. I am saying, I have shown here how to do the calculation. I am saying, please don't do the multiplication on the right hand side. Please don't multiply 306 with 657. Please don't multiply, because that will be a larger number. Rather than that, you can see this step. I have kept 306 as it is. I have kept 306 as it is, 657 as it is, and 9 I have taken in the denominator. Then few cancellation we have done, and we got the answer as a 22338. Is it clear to everyone?
Yes, ma'am. Yes, ma'am.
So whenever in the question LCM is given, HCF is asked, and or like this one, HCF is given and LCM is asked. And if it is two numbers only, okay, we are not talking about three numbers. Whenever we will be having three numbers, let's say the other question is find LCM and HCF of 12, 15 and 21. Now here the previous formula is not applicable over here. We cannot say the LCM into HCF is equals to product of all the number. We cannot say. That formula is only applicable for two numbers. Okay. So here we are having three different number. We will be finding LCM. We will be finding HCF by prime factorization method. Please let me know what are you getting as a LCM and what are you getting as a HCF. Please do it.
Ma'am, I got 420 as the LCM.
420 as LCM. Alvina, you got. And HCF is?
Oh, I didn't find that yet.
Yeah, check it.
Ma'am, I got HCF as 3 and LCM as 3780.
Is it so?
Yes, ma'am.
Okay. Okay, Aisha, I have kept your response over here. Yes, rest of the students.
Ma'am, I got HCF as 3.
Okay, okay, Efra, sure. Okay.
Ma'am,
Yeah.
I got the HCF as 3.
Okay, Albina, you are saying you got HCF as a 3, right?
Yeah.
Yeah. Rest of the Abdul. Abdul, what are you getting, Abdul? Are you doing it, Abdul?
Yes.
I am waiting for your response. Please let me know what are you getting. We just need to do the prime factorization of each and every number, and we have to check what is SCF and what is LCM. Have you done, Abdul? Please let me know whether you have tried it or not. Let's see what are we going to get. 12 is equals to, if we will do the prime factorization, we will be getting 2 into 2 into 3. That means 2 is square into 3 we can write. Okay, 15. Prime factorization I am saying, so you can see prime numbers I have used. 3 into 5. 21. 3 into 7. HCF, just the common term, just the common number which is there in each and every prime factorization. 2 is square is here, 2 is not there, 3 is here, 3 is here, 3 is here, HCF is 3. LCM, which is perfect. Okay, Aisha and Alvina, you both have got 3 only. LCM, we will be taking the highest power. First we'll be taking the common. So 3 is there, we'll be taking the common number. Then whatever is the remaining, that also we need to take. So 2 is square is the remaining, that also we need to take here. 5 is the remaining number, that also we need to take here. 7 is the remaining number, that also we need to take. While finding the LCM, let's do the multiplication. So 3 into 4 into 5 into 7. 4 3 times 12. 12 into 5 into 7. We need to do the multiplication. 12 5 times 60 into 7. We are getting 420. Yes, Alvina, 420 you said, it is correct. Aisha, are we getting 3780?
Ma'am, I
Can you
wrote
see?
3 as 3 cube. That's why I was getting that answer.
Okay, it will not be 3 cube. Can you see it? For when we are finding the LCM, first we have to write the common part. Okay, the common number which is there in each and every term. If you are thinking about previous day, we have taken 2 square. Why we have taken so? We were having 6 and 20. And 6 we have written as a 2 into 3. And 20 we have written as a 2 square into 5. I said that we need to write this 2 is there, this 2 is square is there. So we need to write the maximum power. That is fine. But eventually we are using the same concept. Can you see? 2 square means 2 into 2. This 2 and this 2 is common. For this 2 common part, we need to write 1, 2 in the LCM. Right? And then whatever is the remaining, right? So remaining is 1 more 2. Can you see it, Aisha? Can you see? So when I am saying maximum power we have to write, that means yes, we are taking in consideration. First we are writing the common term, and then whatever extras are there, that also we are writing. Getting it?
Yes, ma'am.
Is it clear, Aisha?
Yes, ma'am.
Okay, this is how we need to do it. Abdul, still you have not responded. What you have done? Have you got HCF as a 3? Have you got LCM as a 420? Now the next question. Today you are going to give the assessment, okay? Which is based on this concept, the fundamental theorem of arithmetic. Next question is, there is a circular path around a sport field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at same point and at the same time and go in the same direction. After how many minutes they will they meet again? If starting at a meet again. So this is what we are having the question. There is a circular park around a sports field. Sonia take 18 minutes to drive one complete round of the field, while Ravi take total 12 minutes to drive one complete round of the field. Okay, suppose they both start at the same point. They both are going to start at the same point at the same time. Okay, so, and they both are going in same direction. So after how many minutes they will meet again? Are we going to make the diagram? Are we going to understand what exactly the whole question says? See, whenever we are having this question, this type of question, where like two persons are there and both the person are taking
Mama
for
got
the
the
first
answer.
person. Yeah, what we have to do?
You have to take the LCM.
Exactly. Whenever we are having this type of this type of word problem, where like a story will be there in one person is taking this much time to cover to do a certain work. Another person is taking the like different time to do the same work, and both are starting at the same time. Okay, at the same time at a same place, both are going to start. Now how after how many minutes, after how many hour will they meet again? If this type of question you are having, then we just have to do one thing over here. We have to find the LCM of the given numbers. Whatever number you can see in this much longer word problem, search the number. I can see one number is 18 minutes, another number is 12 minutes. These two are the only number which is mentioned over here. These two numbers LCM we are going to find. Okay, the same question you will get, that two trains are going in the same direction. One is taking this much time to cover a certain distance. Another is taking another time to cover the same distance. Okay, both are moving in the same direction. And if the last statement is like this, after how many minutes they will meet, after how many hour they will meet, after what time they will meet again, that means we have to find the LCM. This, the same question can be in the form of bell pattern also, that one bell is ringing at this particular time, another bell is ringing at this time, the third bell is ringing at this time. Now find after how much like time again all the bells will ring together. This last statement, if this is like you are having the last statement, that after how long all the bell are going to ring again, after how long both the person are going to meet again, here you just have to find the LCM of the given numbers, the numbers which you can see in the question. 18 minute is there, 12 minute is there, we just have to find the LCM over here of 18 and 2. Okay, so whatever story there, whatever story we are having over here, we don't have to worry about the story. We need to understand in this type of question, we just have to find the LCM. Okay, now in our word problem, the story problem, the question can also be like this, like in the this type of a story, this type of word problem can be there. And in the question, if there is a word minimum, lowest, least, okay, that means it is indicating that we have to find the LCM. If in our question there is a words like largest, highest, maximum, that means it is indicating that we have to find the HCF. Okay, so apart from this type of question which we have taken over here, where it is asking after how long both the person will meet again, if they are starting at the same time at the same place, here we have to find the LCM. This is one type of problem. Another type of problem I have written over here in the question, it will be mentioned this type of word will be there, minimum will be there, or maybe lowest will be there, or maybe least will be there. So we have to understand, in the question we don't have to do anything, we just have to find the LCM of the given numbers. Okay, other type of question, this is type 2. Okay, and type 3 of question will be having this type of word, that is largest, highest, maximum. If this type of words you can see in the question, that means it is indicating, it is giving us the hint that we need to find the HCF. Clear so far? Is
Yes,
it clear?
ma'am.
Now, whatever be the story, we don't have to focus that much on the story. We don't have to make the diagram and try to understand what the whole scenario is talking about. We will just pick this hint word and we will find the answer. Now the next question over here is explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. Explain why these two are composite numbers. The first one and the second one, these two are composite number. Explain it why. So let's take the first number. The first number, that is 7 into 11 into 13 plus 13. Okay, let's take this first one. 7 into 11 into 13 plus 13. In the question, it is already given that it's a composite number. We are supposed to explain why it is composite number. So whenever we are having such question, what we will do here, if you will look at the question, can you see that we can take out common factor? Can you please let me know what can be taken out as a common factor from these two terms? I'm talking about which two term? I'm talking about this is one of the term and this is another term. Why I'm saying just two terms? We can see so many numbers. If we can see so many numbers, we must be clear that multiplication means a single term only. Multiplication, if I will multiply 2 with x, it is 2x. It's a one term, monomial. Okay. If we will multiply this 2x with y, still 2xy is a single term. It's a one term. Okay. And if I will add a number with this 2xy, if I will add z, now here we are having one term and another term, two terms we are having. That's called binomial. Have you done that? Have you done that? Have you seen this monomial, binomial, trinomial?
Yes, ma'am.
Yes. So that's why I am saying that 7 into 11 into 13, these are in multiplication. It's the same. Like all are just attached with each other. All are just single unit. Okay, a single term we are having 7 into 11 into 13 into 14 into 15, whatever will be there in the multiplication. So many numbers you will be able to see. But if all are in multiplication, it's a single term. Okay, so here we are having two term, one term, another term. Now let me know what is common in these two terms.
13.
13 is common.
13 is common. So we can take out 13 as a common factor, right? What will be remaining?
7 into 11 plus 1.
7 into 11 from the first term plus 1 from the second term. This is what we will be having remaining. Okay. Now we are going to say that since the given expression can be written like this 13 into another number, that means it's a composite number. Why we are declaring here only it's a composite number? Because prime number is having just two factors. Prime number is having exactly two factors. If I am writing a prime number 23, it is having exactly two factors, one and the number itself. If we want to factorize this prime number 23, we won't be able to factorize. We can represent it like 1 into 23 only. If we are having a prime number 19, we can just write it as a 1 into 19. If we are having a prime number 17, we can just write it as a 1 into 17. There is no other way. So the given number, we have got product of 13 into any other number. That means it can't be prime, right? Right? It is not a prime. Yes or no?
Yes, ma'am.
If you want to calculate the bracket term, you can do the calculation. 11 into 777 plus to represent the given expression as a product of two integers, it is not a prime number, it is a composite number. Okay, it is having more than two factors. Prime number is having just two factors, exactly two factors. Composite number is having more than two factors. Since we are able to represent it as a product of two different integers, that means it can't be prime. It is a composite number. Yes or no?
Yes, ma'am.
So here we will write, since we can represent the given expression as product of two integers, hence it has more than two factors. Therefore, it is composite number. Clear? Is it clear? Yes or no? Aisha, Alvina, Ifra,
Yes,
Abdul.
yes, ma'am.
Similarly, we are having one more expression over here, and we have to show that whether it is a composite. We have to explain that why it is also composite number. So we are having 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Please do it. Okay, please do
Ma'am,
it.
can you scroll up? I
Scroll
want to
up.
see it. Yeah.
This one.
Yes.
Okay.
I got the answer.
Yes, yes, Alvina, you said no to scroll over here
Ma'am,
after
Aisha.
noting it down. Okay, Aisha, you said
No, I did not say this. I'm saying I got
you
the
said the
answer.
answer. Yeah. Yes, Alvina, once you are done with noting it down, please let me know. Rest of the student, have you noted it down in your copy? Abdul, are you getting it?
Yes.
Okay.
Done, ma'am. I wrote.
Okay. Please do this one. Note it down no? Quickly and do it. Aisha, you have done. We are coming to this one. Let me
Yes, ma'am.
inform that you all are going to give the assessment today, which is related to this topic. That is uh, fundamental theorem of arithmetic. LCM, SCF will be there. Okay. Note down this expression, this one, and just give me a second. Are you done with it? Here also we can take a common factor from these two terms. We can take out a common factor. Yes, Aisha, you are done with it. Can you please let me know what you have done?
Ma'am, I took 5 as a factor. And
Yes,
in bracket 7 into 6 into 4 into 3 into 2 into 1 plus 1.
yes, perfect. And from here only we can declare, since we are able to represent it as a product of two integers, hence it's a composite number. The statement which we have written previously, the same statement we need to write for the other expression also. Since these two both are given in the same question, so the statement we will be writing once only. For both the expression, we can represent as product of two integer. Hence, it has more than two factor. Therefore, it's a composite number. Clear? Is it clear to everyone?
Ma'am, why 1 is coming? +1.
Because we have taken 5 as a common, no, Abdul? This
Yes.
5 we have taken as a common factor from here and from here. So what is remaining from the first term? This is our first term. Can you see?
Yes.
Let me wipe it. This is our first term. Remaining are left. And from the next circle part, 5 we have taken common. So 1 will be there, no, Abdul?
Yes.
Is it getting clear? Now we can leave our steps over here. We can leave here and we can write the statement. Or if you want, you can still do, you can do the calculation for the bracket and then you can write whatever result you are getting. Okay?
Yes.
Any confusion to anyone? Alvina,
No,
Aisha,
ma'am.
Abdul, Ifra, any confusion? Ifra has already left. Any